Most people picture the dangers of westward travel as mountain passes, hostile weather, or running out of food. And those things absolutely killed people. But if you go back and read the emigrant journals from the Oregon Trail, the Santa Fe Trail, the California Trail, and the routes through the Great Basin, one threat shows up over and over again in a way that most history classes never talk about: water. Specifically, the wrong assumptions people made about what water was safe to drink and what was going to put them in the ground. And the dangerous part was not that safe water was hard to find. The dangerous part was that the water that killed people often looked perfectly fine. Hit subscribe before we get into it, because this channel covers the practical side of frontier history, the decisions that saved lives, the mistakes that ended them, and what any of that means for people spending time outdoors today. I'm Jerry Davis, and the more you study emigrant trail history, the more you realize that the biggest killers were not dramatic. They were quiet. A stream that looked clear, a spring that smelled fine, a barrel of water filled from the wrong source. The frontier did not always announce itself as dangerous. That was the problem. By the end of this video, you'll understand what actually made water lethal on the frontier, why pioneers made the choices they did, why those choices were sometimes unavoidable and sometimes just catastrophically wrong, and what the underlying principles mean for anyone camping, backpacking, or sourcing water off-grid today. Let's start with the assumption that destroyed more emigrant parties than almost anything else: clear water is safe water. That idea made a certain amount of sense in the world these travelers came from. Back east, murky water was associated with swamps, disease, and bad air. A theory called miasma that blamed illness on contaminated air rather than contaminated water. The germ theory of disease was not widely understood or accepted in the mid-1800s, when the great emigrant migrations were at their peak. Physicians, educated people, and ordinary travelers were all working with incomplete information about what actually made people sick. So, when a wagon party came to a stream that ran clear and cold over smooth gravel, the visual signal was, "This is good water." When a pool looked brown or murky, the signal was, "This is bad water." That logic was not entirely stupid, given what they knew, but it was wrong in ways that killed thousands of people. The first problem was alkali water. Across the Great Plains, through the desert country of present-day Nevada and Utah, and along significant stretches of several major emigrant routes, the ground contains high concentrations of sodium carbonate, sodium sulfate, and other mineral salts that leach into water sources. This water can look completely clear. It can run in what appears to be a normal creek or pool, but the alkalinity makes it toxic to livestock, and at high enough concentrations, dangerous or fatal to humans as well. Period accounts from emigrant journals describe stretches of trail where livestock began staggering and dying after drinking from streams that showed no obvious warning signs. Some parties lost oxen, mules, and horses within hours of a water stop. Others watched animals suffer and die slowly over a day or two. The Humboldt River corridor in present-day Nevada had a particularly brutal reputation. Journals from multiple parties describe the Humboldt Sink, the point where the river disappears into the desert, as one of the most dangerous water environments on the entire overland route. The water became progressively more alkaline as it moved toward the sink, and the ground around it was streaked with white mineral deposits that experienced travelers learned to read as a warning. But for parties making the crossing for the first time with no guide and no prior knowledge, that warning was easy to miss. Now, here is where the trade-off gets complicated. Parties that recognized alkali water sometimes overcorrected. Historical accounts describe emigrants dumping or avoiding water sources that were actually safe, rationing badly, and then driving livestock and themselves into serious dehydration trying to reach a known good source. Dehydration in desert summer heat is its own kind of death sentence. So the choice was sometimes between two bad options: risk the water in front of you, or push forward without water and hope the next source was better. That is the kind of decision that does not have a clean answer. Experienced guides and mountain men who had worked the region had learned to check for certain signs. The white crust around the edges of a pool or along the bank, a slight slick sheen on standing water, a bitter or soapy taste in small amounts, the way livestock hesitated or refused to drink even when thirsty. Animals were not infallible at detecting alkali water. They would drink it when thirsty enough, but a horse or mule that pulled back from water that looked fine was worth paying attention to. That brings up the second major problem: the sources that were chemically safe but biologically lethal. Cholera. Cholera is caused by a bacterium, Vibrio cholerae, spread through water or food contaminated with fecal matter. In the mid-19th century, nobody understood that mechanism. What they knew was that people got violently ill with severe vomiting and diarrhea, became critically dehydrated within hours, and frequently died within a day or two of the first symptoms. They did not know why. They did not know the water was doing it. The Oregon Trail period saw major cholera outbreaks, particularly in the late 1840s and into the 1850s, corresponding with global cholera pandemic waves that moved through ports and then along trade and migration routes. Historical accounts from the peak migration years describe graves along the trail at intervals that make clear how devastating the disease was. Parties that started with 20 or 30 people sometimes arrived at their destination with less than half that number. Here is the critical part that most people do not think about. The cholera contamination was not coming from some distant natural source. In many cases, parties were contaminating their own water supply by camping near it, relieving themselves near it, or filling water containers downstream from other groups who had been doing the same thing. Wagon trains moved in sequence along the same routes. Thousands of people traveled through the same corridors in the same seasons. At popular campsites near reliable water sources, the ground around the water had been used as a latrine by previous parties. Rain, runoff, and normal seepage moved that contamination into the water source. The next party arrived, saw a creek running clear, filled their barrels, and drank cholera. The cruel irony is that the high-traffic, well-documented, well-known water sources, the ones that guides pointed to as reliable, were often the most contaminated precisely because so many people had been using them. A remote, difficult-to-reach spring with no established campsite nearby was sometimes the safest option. But parties under time pressure, managing exhausted livestock, and following the known road did not always have the luxury of going off-route to find a better source. The third problem is one that modern outdoors people still get wrong: the assumption that moving water is safe water. Running water dilutes contamination. That is true as far as it goes. A fast-moving stream disperses biological material more than a stagnant pool does. But dilution is not purification. A creek with cholera in it is still a creek with cholera in it. Upstream contamination from a camp, a carcass, a buffalo wallow, or another water source feeding into the main channel traveled downstream to everyone drawing from it further along. The water was moving. The pathogen was moving with it. Buffalo wallows deserve their own mention here. These were shallow depressions in the prairie where bison had rolled, trampled, and deposited waste over many years. After rain, they filled with water. On a dry stretch of trail with nothing else available, a wallow full of brown, muddy water was sometimes the only option for livestock. Period sources note that animals watered at wallows frequently suffered afterward, and some did not survive. The sediment and biological contamination in those shallow depressions was severe. Parties in desperate circumstances drank that water themselves after straining it through cloth, which reduced the visible sediment but did nothing about the pathogens. Straining through cloth is worth addressing directly, because it is one of those techniques that sounds like a practical solution until you understand what it does and does not do. A cloth filter removes large particles. It removes sediment, debris, and visible material. It makes the water look better. It does not remove dissolved minerals. It does not remove bacteria. It does not remove the Vibrio cholerae that was killing people by the thousands. Pioneers who strained their water and then thought they had made it safe had only made it look safe. That distinction cost lives. Boiling was understood in some form, but inconsistently practiced and inconsistently understood. Some period sources mention boiling water as a precaution against illness. Others suggest that the concept of boiling as a purification method was known more from a practical cooking standpoint than from a biological one. What people largely did not understand was why it worked. They did not have the framework of germ theory to explain that heat was killing microorganisms. Some believed boiling removed something from the air above the water. Some boiled water when they had the fuel and time, and did not when they did not. The fuel issue is practical and worth emphasizing. Boiling water requires fire and time. Parties moving through open prairie where wood was scarce, or pushing hard through desert country trying to make mileage before the heat of the day, did not always have either. Buffalo chips, dried bison dung, were the primary fuel source across much of the Great Plains, and they burned hot enough to cook food and boil water. But gathering them took time, and the supply was not always consistent. In the worst conditions, people were making the rational calculation that stopping to build a fire and boil water cost them travel time, and travel time could also get them killed. Every decision on the trail existed inside a web of other constraints. There was also the spring water myth. Springs have a strong reputation, culturally and historically, as reliably pure water sources. And springs often are significantly safer than surface water, because the ground itself provides filtration as water moves through it. But not all springs are equal, and several accounts from the emigrant period describe springs that were problematic for reasons that were not immediately obvious. Some springs in the desert Southwest are associated with geothermal activity and contain naturally occurring compounds that make them unsafe. Historical accounts describe what travelers called poison springs, sources where animals and sometimes people became sick after drinking. Some of these were likely high in arsenic, hydrogen sulfide, or other mineral compounds. A spring that smelled of sulfur was usually avoided, but a spring that looked clear and cold and showed no obvious warning signs was not always safe. There is also the matter of how spring areas were used by wildlife and previous travelers. A spring that had been used as a campsite, with human and animal waste accumulating nearby over a season of emigrant travel, could develop surface contamination even if the spring itself was fundamentally clean. Where the spring water exited the ground, it might be clean. Where it collected in a pool or trough at the surface, with animals standing in it and camps nearby, it was a different situation entirely. Now, what does any of this mean for modern campers, backpackers, or people trying to live off-grid? A few things. The visual cues that pioneers relied on, clarity, color, smell, the absence of obvious warning signs, are still worth paying attention to. Turbid, discolored, or foul-smelling water is usually signaling a problem. But clear, cold, fast-running water is not an automatic pass. You still need to treat it. The pathogens that made pioneer travel lethal are still present in backcountry water sources today. Giardia and Cryptosporidium are the most common concerns for modern backpackers, and neither is visible to the naked eye. Neither makes water look or smell different, and neither cares that the stream looks pristine. Modern filtration systems and chemical treatment tablets do things that 19th century cloth straining could not do. A quality ceramic or hollow fiber filter removes protozoa and bacteria from water. UV treatment devices work on protozoa and bacteria. Neither alone handles every possible chemical contamination. For that, you need an activated carbon element, or you need to know your source. Boiling remains reliable for biological contamination, if you reach a full rolling boil. For homesteaders and off-grid builders thinking about water sourcing, the principles that made springs and dug wells safer than surface water on the frontier still apply. Protecting the source from surface runoff and animal access, locating sanitation downhill and downstream from water sources, keeping waste well away from any collection point, these are not new ideas. They are the ideas that healthy, long-established settlements understood and that parties moving through unfamiliar territory often did not have the time or knowledge to implement. The upstream-downstream rule is simple and worth permanently internalizing. Sanitation goes downstream and downhill from water. Camp downstream from your water source. Drinking water comes from above where you and your animals are working and resting. That single principle, applied consistently, would have prevented an enormous percentage of the waterborne disease deaths on the emigrant trails. The alkali water problem has a modern parallel in the sense that ground-level mineral contamination is still real in certain regions, and water that looks perfectly clean can be chemically problematic. If you are sourcing water in unfamiliar desert country, testing matters. The white crust along the banks, the absence of healthy vegetation right at the water's edge, the slick look on standing pools, those are still worth reading as warning signs, even if you have a filter. The deeper lesson from all of this is the one that keeps coming up when you study frontier history carefully. The most dangerous situations were not the dramatic ones. They were the situations where everything looked fine, where the water looked clear and cold, where the campsite was right next to the water source out of obvious convenience, where the known trail led through a water stop that hundreds of other parties had used, where the logical, obvious choice was also the deadly one. The pioneers who survived the longest were not necessarily the bravest or the strongest. They were often the ones who had learned from experience, from a good guide, or from the hard lessons of parties ahead of them on the trail, to look past the obvious surface reading of a situation and ask the next question. That water looks clean, but where has it been? That spring looks reliable, but where is the camp? And where is the waste? The creek is running, but what is upstream? Good questions on the frontier. Good questions now. I'm Jerry Davis. If you found this useful, hit subscribe. We'll keep going.